All right, folks, we're going to start with chapter 2. We're going to talk about the differentiation, which relates to the derivative. All right. Now, derivative is one of the most important concepts of calculus. As a matter of fact, the derivative and the integral are the two most important because they deal with so much of what you're going to be learning in this class. So let's go ahead and let's go over to the following. Now, you can do this information on your own, but I'm going to go ahead and I'm going to show you what it looks like. Okay, now I got my notes with me because I want to make sure I'm going to try to be as accurate as possible as I can. Well, it's going to look something like this. I got a dot there. Now, mind you, it's not the most accurate, but it's okay. All right, now that's the graph. So we've done that. Next, it says sketch the tangent lines at x equals -1, x equals 0, and x equals 2. Okay, so now here's what you got to do. You got to kind of estimate it. All right, you can practice this on your own, but if you look at it, if I take the estimated tangent at x equals -1, the slope is going to be approximately 1. Now, if I do the same thing at x equals 0, the slope's going to be 0 because it's a flat line. Because what happens is the curve, it flattens, then it starts to go down. And then at -2, pardon me, at x equals 2, way down here, the slope is +4. Now you can check that with the points at there, but it's just something to kind of get an estimate on. Okay, now we figured out we did part 2 and we also did part 3, and then it says write equation for the 3 tangent lines that you just drew. You can do that on your own. Okay, now what is a tangent line? Here are some examples of tangent lines. The tangent line drawn of the curve f of x at a given point. Now, what we're going to be talking about is you have been dealing with slopes of lines between 2 points. Calculus is based on instantaneous slope, meaning the slope at 1 point. That's what we'll be focusing on from this point on. So it's a little bit different for you. It takes a little getting used to, but you're young and you'll bounce back eventually, okay? So I'm just telling you that right now. All right, trying to move it up a little bit so y'all can see better. Okay, so the definition of a slope with a slope of m. Here it is. And I'm going to highlight it for you, and I'm going to go ahead and I will post this. I will, of course, post this on my Canvas page. It says if f is defined on an open interval containing c and the limit as delta x approaches 0 is f of c plus delta x minus f of c all over delta x. That equals m. Okay. Then then the line passing through the point c, comma f of c with the slope of m is the tangent line to the graph of f at the point c, comma f of c. All right. Now that may not make a lot of sense at this moment, but as we go through this, you're going to see better of what I mean. Okay. So here's what we're going to have to say. It says determine the slope of the line tangent of f of x when x is equal to 2. Okay, so there's a couple things we have to compute first. First, we have to compute f of 2. F of 2 equals, just simply plug it in, so 3 times 2 plus 1 equals 7. Okay, so f of 2 equals 7. Now, f of 2 plus delta x, where delta x is the change in x. When you see the little triangle symbol, that means delta. Delta means change. So let's talk about the change in x. So here's how that's written. That is going to be 3 times 2 plus delta x plus 1. And there's a parenthesis around there that I forgot. All right, so Now, to determine the slope of the tangent line, here's what we do. We simply take the limit as delta x approaches 0 of f of 2 plus delta x minus f of 2 all over delta x. And that is straight from the previous formula we just dealt with, okay? So, and I figured these components up earlier so you could see where they come from. So now I'm going to take the limit of delta x as delta x approaches 0, excuse me, of, and then when I simplify that, I get 6 plus 3 delta x plus 1 minus 7. Now this, and I want to highlight, so this right here is this, and this right there is this. I'm highlighting so you can look back and see later, okay? So, and then of course that is all over delta x, okay? So, then when we simplify, 6 plus 1 is 7 minus 7, I'm left with 3 delta x over delta x, which means that the limit as delta x approaches 0 is just simply 3. Just simply 3. All right. Well, you're probably thinking, well, I could have just looked in front of the x. Well, yeah, but that ain't always going to be the case. I want you to see how it works and why it works that way. Okay, so let's go ahead and let's do another one because I'm going to see how much time I have. I'll probably have time to do one more, and then there's going to be a long limit process that I'm going to go over with you. We're spending a lot of time on this stuff because this is a very essential topic in this course. Okay, so it says determine the slope of the line tangent of g of x equals x squared minus 2 when x equals negative 1. All right, so here's what we need to determine. First, f of negative 1 is going to be negative 1 squared minus 2, which is negative 1. And then f of is going to be x plus delta x. And actually, I wrote that wrong, so let me fix that. Negative 1 plus delta x equals. In this case, it is going to be delta x squared minus 2 delta x and that's going to be plus 1 minus 2. Because what happens is I plugged this right here in for x squared, and I'm going to write it down here, delta x minus 1 squared equals delta x squared minus 2 delta x plus 1, and then, of course, minus 2. All right, so the limit as delta x approaches 0 of the following, of f of delta x, and I'm going to grab these because I keep going back and forth. I'm trying to make sure that I write this correctly for y'all because I don't want you to come back on it later. I'm trying to be as thorough as I can. Equals, and I'm going to run out of room here in a minute, so we have all this, which is delta x squared minus 2 delta x plus 1 minus 2, and then minus what we said over here that was minus -1. So, which of course is plus 1. And then that, of course, is over delta x. All right, so what we do then, simplify the terms. Now that becomes plus positive, so the 2's cancel out, and I'm left with delta x squared minus 2 delta x all over delta x. Now, this will simplify, excuse me, and this will give us delta x minus 2, and the limit as delta x approaches 0 is just going to be simply 0 minus 2, which is just simply -2. So the limit when x approaches -1, or the slope when x approaches -1, is -2. So I'm going to write it up here, m equals -2. All right. I'm going to be running out of time here, so I'm going to go over some more of this with you here in the next video. I'm also going to include a special video on the limit process, because as we're going to get through some tougher material, you're going to be seeing some more complex equations. So I'm going to have a special video on that as well. So once you get through this particular section, it gets a little easier to work with. And then in 2.2, I'll show you some things that'll make it easier. But right now, you got to understand this process. I struggled with this when I took it. So I'm going to try to put a little bit more time to make sure that you have a good grasp on it. Okay, we'll talk more in the next video.